As we start topic 4 of module 6, we're going to deal with properties of logarithmic functions. And remember, logs are exponents. And if you recall earlier in the course, we talked about the product rule. If we're multiplying variables, we just add the exponents. So copy this down. This is going to be useful if you get stuck on something. So multiplication is indicated through addition. And here we're dealing with our logarithms. Now, when we are dividing, as we show here, where we added in multiplication, in division, we're going to subtract. So anytime you see subtraction of our exponents in these logarithmic functions, that indicates that you're going to divide. Okay, so with this background, let's start on some specific examples. And since this is sort of jammed up on your page, you may want to put much of this over on the left of your booklet. So express as an equivalent expression, that is the sum of logarithms. Okay, so there's what you have. So we're going to write it log of base 3. That part stays the same. And then we're going to have this 3 here. And now we're going to put, since this is multiplication, we're going to put addition plus log of base 3 of 81. So we have separated this into the sum of logarithms. And the 3 plus 81 indicates that we were multiplying this originally. Okay, now here they're asking us to express as a single logarithm something that was in addition. So we're converting this to this form. And it'll look like this. Log base A of, and then you put it in parentheses, 10 times 6. And we could actually simplify that, and that becomes log base A of 60. So the idea that we could separate that into this is going to be useful as we do calculations a little later on. All right, let's raise it up. Okay, now for this one, this is a little different because now we have an exponent up there. And this is sort of the power rule, that when we raise powers, 2 powers, it's multiplication and not addition. So this will be the model for this one. You write log of base x. That part stays the same. But we now take the exponent to indicate that we're going to multiply and put it in front. And then we put the 15 there. Now in letter B, we have to convert from the radical form to its exponential form. So in a sense, this is going to be log base 5, and our A here is going to be to the 1/4 power. Now, we don't leave exponents there. This we put the exponent in front. And our final answer looks like this. Okay, so we're just giving you a new rule here. This is raising a power to a power, so we have to multiply. And we can indicate that multiplication by putting it in front of the log. We have to convert this radical from its radical form to its exponential, fractional exponential form, and then put this exponent in the front. Now, looking at example 3a, let me write this again, so I don't like the way this is written. So log base n, and then we have 10 divided by L. All right, now here, this is division. It just looks a little funny that way. So this would be equivalent to log base m of 10. Now, since this is division, we convert that to subtraction log base m of L. And that is our answer. Now in letter B, they want us to list it in a single logarithm form. So that would be log base z. It's kind of hard to read there. Now this is going to be 7 on top, and then since it's negative, we put the 10 underneath. So there's the answer to letter 3B. All right, let's go on. Now in example 4, as we look at it, these are single logs. They want it in the expanded version. So let's write it carefully. Log of base x. Now here this is going to be an a, but the exponent 2 goes to the front. And you got to be sure this is not taken as 1 here. That's log. Okay. Now we have a subtraction because of the division bar. So minus log base x of b. Now another division, so we indicate that by subtraction. But this has a exponent, so we need to put that exponent first. Log base x of c. And that's the answer here. And again, that log, let me put an L there. We go. Here it's not confusing. There it might be. Okay. All right, now we want to deal with this radical. So the first thing we have to do is convert it from radical notation, that looks like base y, to, this is the, put in parentheses here, this is to the 1/2 power, and it's a over b to the 3rd c. Now, for something like this, where the whole expression here is to the 1/2 power, we start off by putting it to the 1/2 power. And then we're going to put everything in a parenthesis here. I don't know how big it's going to be, but it's there. So that's this 1/2 that's out there. So now we go log base y of a, and then this is division, so we're going to do subtraction, log base y, and it's b, so we need to put that 3 out in front there, and then we have minus log base y of c. Okay, so check your work. Here we had to convert its radical form to its exponential form, and then move this exponent out to the front of the whole thing, and then we're dealing just with what's in the parentheses, individually showing division by subtraction, and putting this 3 in front of the log over here. Okay. Now, for letter C, we want to have this spread out expression into a single logarithmic expression. So let's study it a little bit here. Okay, so it's going to be log base a, and then it's x here, and I'm going to put a division bar because I see some subtractions in there, and we're going to put this x, bringing that 3 there to the 3rd power. Now here it's a negative, so that's going to go in the denominator as an a to this 4 here. So the negative is what brings it down to the denominator, and then the 4 is the exponent of the, not the a, the y. The a is our base, and we already have that there. Okay, so we now have this, which is log of a, which we have already. It's a plus, so this is going to go up into the numerator. Now it's to the 1/2 power, so that's going to be radical z. So it's a little confusing. Again, log base a. Then we put our x in the numerator. The 3 is the exponent. We take our negative 4, and that means it's going to be division of y, y to the 4th. There we go. And then plus, back in the numerator, log base a, which we have already, z to the 1/2 power, which is the square root of z. All right. In letter D now, this is a little tricky, but let's put it out here. Log base a. So we're finished with that. Now we have this, which is the square root of x over y, and it's just going to be times, because there's our plus, we're going to multiply this by xy. Now notice when you have something like this, you can actually cancel out, and I'll show it in blue, this y with this y. So you end up with log base a of x, the square root of x. That's what you have left. Now, to me, this would be a perfectly acceptable answer. To get the answer they have down below, we'd have to convert this part, let's do it over here, x times x to the 1/2 power. We're converting this radical form to its exponential form. Now by this x there's a 1 there that we're going to make 2 over 2, which is 1. But now we can add them, and we get log base A x to the 3/2. Again, I personally would do it this way, but this is what they're showing. And I haven't mentioned this, but again, I've mentioned it before, you know, show your work, because we can give you partial credit, or in some cases full credit, because we would accept that answer where MATLAB may not. All right, let's go on. Now in letter E, they're giving us some logarithmic values. They're saying the log of 3 is this, the log of 4 to this base is this, and it's saying use properties of logarithms to calculate a numerical value for each of the following if possible. So here's where it takes a little bit of analysis looking at what we have. Now notice what we have here. If I separate this, I get log base A of 12 is 4 times 3, so I can write it this way. So I have here the log of 4, and I have the log of 3. So to get an answer for this, I just add my values. That's what the previous examples were showing us to do. So this is the single form. We separated. They're giving us a value now of 3 and 4, which we have right there. We add them together. This is our answer. Now, without doing this, you can see, what are we going to do here? Well, we have 3, which is this. And we have 4, which is this. But what are we going to do here? We're going to subtract. All right, so we bring this 4 up, changes its sign. So here we're going to subtract a negative 0.147. Now remember, you can't really subtract this way. You have to theoretically put this number on top, subtract this, and note that it's negative. Or just put this into your calculator, it'll give you this value. Now in letter G, it's going to take a little bit of challenge here. So remember, we said that if we convert this, in fact, let's write it up here, log base A, and I'm going to say that 64 is 4 cubed. I think you'd all go along with that. 4 to the 3rd power. Now, how would we write that? Well, it would be the 3rd log, or 3 log, move the exponent to the front, base A, and then it would be 4. So what do we do here? Well, here we're going to multiply 3 times what the value for 4 is, which is this, 0.712. And again, this previous techniques we've been working on allow us to do this. So then this becomes 2136. Just put that in your calculator. 3 times this. So it allowed us to do it. Now, how about this one? Again, this is a little tricky because this is a 1. Now, what did we say the exponent of 1 always is? And the answer is 0. So we had to know that from previous lessons. And now we're going to subtract this from 0. So in a sense, it just becomes our answer here, 0.712, but a negative 0.712. This is our answer. Now for letter I, this is a real tricky one. I'm going to separate it into its 2 parts. So it's log base A of 3 plus log base A of A. Now we had mentioned in an earlier example, whenever we have this relationship, and you might say, well, what's the exponent there? 1. When you have this relationship, this value is 1. So we have 3, which is 0.565 plus 1 now. This is a little tricky, and the answer for this one is 1.565. Okay, now as we look at this one, log of base A, log base A of 7. Now, do we have any values for 7? Well, if it was, theoretically you could say it's 1 times 7, but we don't have values for that up there. So this is one where there is cannot be found. Okay, now we're going to work on some of these. Now this is similar to one we just did, and whenever you have this arrangement, log of base 4, 4 to the 15th, this 4 over 4 is in a sense 1, and the answer is 15. It's whatever is the exponent. And here we have log 11, base 11 of 11, and this is the exponent. This part here is a 1, and it's just this exponent part as the answer. Now if you look in your textbook, they do give a rationale, a reasoning for this, but the shortcut is when you see this arrangement, it's just the exponent as the answer, because this part is 1. Okay? Since this is 1, in a sense you could put the 15 out here, and 15 times 1 is 15. Alright, that's one way of looking at it. So, 1 comes out here and then times that. Okay, or 1 is there and it's that times 1. Okay, well, that's the answer anyway. Well, all right, good luck. We're going to do a little bit of classwork if we have some time.